Please write down this problem. This is a 8-mark question in your VTU. 4-point sources. 4-point sources are spaced lambda by 6 meters apart. The power is applied with equal magnitude slash amplitude and a phase difference of pi by 3 between adjacent elements. Obtain the field pattern. Obtain the field pattern and find its beam width between first mul's BWFN and half power beam width. Okay, please all of you read the question once, understand before starting the problem. Never start a problem without fully understanding the question. Is it clear? All of you clear?
Yes, sir.
Okay. Please read the question once. Okay. 4-point sources are spaced lambda by 6 meters apart. So your distance D is what? D is
lambda by
lambda by
Lambda by 6.
lambda by 6. The power is applied with equal amplitude but with a phase difference of pi by 3. Listen here. Now this particular statement of this phase difference pi by 3, it is neither broadside array nor end fire array. With the phase difference means it should be 180-degree phase shift for your end fire array. So your pi by 3 is not 180-degree phase shift. So you can't apply either broadside array formula or end fire array formula for this kind of problem. Is it clear? All of
Yes,
you.
sir.
See this particular phase shift of pi by 3. Okay, this is neither your pi by 3 phase shift, what I am telling in the question. So your phase shift of pi by 3 is neither broadside Broadside means no phase shift or end fire. End fire means here it should be 180-degree phase shift. Broadside means 0-degree phase shift. So both it is not coming. So you have to find out now your subsidiary maxima formula. You have to derive it for deriving this equation. So don't worry. 4-point sources means what is the value of n? N is equal to 4.
4.
Agreed? Yes or no?
Yes, sir.
Please reply to me. Yes or no?
Yes, sir.
Okay. So let me go back to the derivation which we did some time back to have a better understanding of what we are trying to speak here. Okay. Please write down this. Psi is equal to beta d cos phi plus alpha. Now write down this equation. Psi is equal to beta d cos phi plus alpha. Please write down. All of you written down. This is from the derivation which I did last week.
Yes, sir.
Okay. So what I have to do is psi is equal to, we know that psi is equal to beta d cos phi plus alpha. Your alpha value is your pi by 3 now. Alpha value is your pi by 3. Is it clear? Okay.
Yes,
So
sir.
what is beta? Beta is equal to 2 pi by lambda. Always remember, in your entire antenna, wherever this beta comes close to eyes, or you can't close eyes and write close to ears, don't think beta is equal to 2 pi by lambda. Is it clear, Kavya? Okay, very good.
Yes,
Mahima,
sir.
is it clear?
Yes, sir.
Okay. So what is the value of D? Lambda by 6. So substitute this in the above equation and find out value of psi. So psi will be equal to beta is 2 pi by lambda, and your D is equal to lambda by 6 cos phi plus pi by 3. Do you agree with this?
Yes, sir.
Lambda will get cancelled. 2 ones are 2 this one. So I can write psi is equal to pi by 3 cos 1 cos phi plus 1. Agreed? Cos phi plus. Having found the value of psi, we have to find direction of maxima and minima. Now, to find the direction, what you need to do is at. Now, this is your direction of maximum. Okay. Okay. Next, you have to find maxima direction. At phi is equal to phi max. Okay. What will be phi max?
1.
Hmm? What will be phi max?
1.
No, angle phi. Yes, correct. What you are telling is right. So what should be phi then? This should be cos of 0, right? Cos 0 is? Okay, now we'll discuss this later. Quickly write down since we are a little short of time. So what I should do is I equate this pi by 3 1 plus 1 plus cos phi max, equate this to 0. See here, unlike that sin psi n psi by 2, we are equating it to 0. This is only we are equating this angle psi. Okay, so for I am equating only the angle psi is equal to 0. So don't get confused now. Please follow the steps which I am trying to do. So 1 plus cos phi max is equal to 0, or your cos phi max will be equal to minus 1. Your phi max will be equal to cos inverse of minus 1. What will be phi max then?
180 degrees.
Plus my correct, exactly, it will be 180 degrees. So you write this as unidirectional pattern. Unidirectional pattern. 180 degree will be your phi max. Okay. Now let us go back to the derivation which we did some time back. See, for null direction we equated this to 0, but this is neither a case of broadside array nor end-fire array. In this case, this psi only we have equated to 0. We have not equated this entire equation. Please get my difference here. See, if you have to do like this, your calculation becomes very complex and the time will be insufficient in a VTU examination to do all this mess. So therefore, we have equated psi to 0 rather than equating the entire thing here and complicating your life. So approximately your answer will be correct and you will get marks. Okay, so don't get confused from what we have done earlier. Clear?
Yes, sir.
Okay.
Yes, sir.
Okay, next you have to find what is known as a subsidiary maximum. Subsidiary maximum. Equate sin n psi by 2 is equal to 0. That is your sin n psi by 2 is equal to 0 means your n psi by 2 is equal to plus minus m pi, where n can be any integer. So in this case, your n is equal to 4 already given. So 4 psi by 2. So 2 ones are 2 twos are. Sorry. Yes. So this will be equal to, that is equal to n by 2, that is 4 by 2. What is psi? Just now we have found. What is psi? Psi is what? Pi by 3 cos of phi. Here you should put a subsidiary maximum plus 1 is equal to plus minus m pi. Is it clear? What is psi? Psi is cos phi plus 1. So So when I'm finding the subsidiary maximum, I'll put here SUB, subsidiary. Got my point? When you draw the plot, you will get it more clear. Is it clear? What I'm trying to do?
Yes, sir.
Mahima, is it clear?
Yes, sir.
Okay. So quickly do this work. So what happens here is this will be 2 ones are 2 twos are, so 2 pi by 3 cos phi subsidiary maximum plus 1 is equal to plus minus m pi. Okay. So if I keep this one here, cos of phi subsidiary maximum is equal to, what happens here, pi will get cancelled, right? Pi will get cancelled. So you will get plus minus 3m by 2. Agreed? Agreed.
Yes, sir.
Yes, sir.
So cos phi of subsidiary maximum will be equal to minus 1 plus minus 3m by 2. Okay. Next. Phi subsidiary maximum will be equal to cos inverse of 3m by 2 minus 1. 3m by 2 minus 1. Put, substitute m is equal to 1. What happens now? Substitute m is equal to 1. So what happens is you will have cos inverse. Okay. So this will be 3 by 2 minus 1. So this will be cos inverse of half. How much will
60
be?
degrees.
Huh?
60 degrees. 60 degrees.
Plus minus 60 degrees. Put m is equal to 2. So what happens here is cos inverse of m will be equal to 2, means that will be 3 2 by 2. 2 will get cancelled, 3 minus 1. So that will be cos inverse of 2. I think you will not get this value. This is known as invalid. So only you have 60 degrees as your subsidiary maximum. So where did you get your maximum direction? 180 degree. Where did you get your subsidiary maximum? At 60 degree. Now all you have to draw is plot this graph. So this will end your question here. So please follow very carefully what I am trying to do. These problems are easy once you understand. So there are some shortcut methods to do it. So once you know these problems, you will get very good marks. Okay, this angle is your 60 degrees. This angle is your 60 degrees. So your phi max value will be here. That is equal to 180 degrees. So how you have to draw is, I'll use a different color. I'll try to draw. If not, I will show you the in the notes this particular problem so that you can draw. So your plot will come something like this. Okay. So please draw this. I'll just show you the notes also so that you can see. See, all these notes I think I have given you already. It has been uploaded. Yes. This is what I have done exactly now. Instead of k, I have taken the integer m. Okay, that is what I have done here. So can you see this plot? All of you?
Yes, sir.
Please draw this plot. Next, you have to find this beam width between the first nulls. Please draw this plot, all of you. Then we can do this beam width between the first nulls. All of you have drawn this? All of you have finished drawing? Mahima, over?
Yes, sir.
Over, no?
Yes, sir.
Purva Chandra Prakash, over?
Not it, sir.
What are you doing with that?
Over, sir.
Okay. All right. I'm trying to use the pointer here, which I'm not getting it. Scanned image. Okay, I'll worry about that later. Now, which is the null direction here? Which is the null direction here? This one, right? This is your NULL null. Can you see that? I'll try to use both and try to explain you. Can you see this? This is your NULL null direction. So next, what you need to do is find the beam width between the first nulls. So how do you find the beam width between the first nulls? What is beam width between the first nulls? Okay, this is your null direction. This is the null direction. So this is the beam width between the first nulls, which is shown by the red color. Can you see this?
Yes,
Or
sir.
no? Yes or no? All of you, are you
Yes,
able
sir.
to see that?
Yes.
Yes, sir.
Okay. So if I want to find this one now, this is your null direction. This is the null direction. So beam width between the first nulls will be this one. So this is known as your beam width between first null. So what will be this beam width between first nulls? Can you tell me now? 360 degrees minus. Oh, what is the total
120.
angle?
120.
What is the total angle? Now we are finding beam width between first nulls. What is the total angle? 360 degrees minus how much I should do?
120 degrees.
So what you will get? 240 degrees. So this is your beam width between the first nulls. So Mahima, what will be Kavya? What will be half power beam width? What will be half power beam width? What is half power beam width? Mahima, do you know?
Sir, we have to divide 240 degrees by
Yes,
2.
yes, yes, excellent. Now what I should do? Beam width between first nulls divided by 2. So this will be 240 degrees divided by 2. That is equal to 120 degrees. So that is your half power beam width and beam width between first nulls. Now take down the next question. Draw the radiation pattern. Draw the radiation pattern. All of you are clear with this problem, pi by 3 problem? This pi by 3 is a unique problem. So you will get some this cardiac shape, this one as your power pattern. Is it clear? All of you clear?
Yes, sir.
Yes, sir.
Okay. Now shall we do the next question?
Yes, sir.
Okay. Can you write this down? Draw the radiation pattern of an array of 4 isotropic point sources separated by a distance of lambda by 2 meters and having a in-phase currents. Derive the equations required. Please write this. So n is equal to 4 here. So n is equal to 4. Okay. So that is your number of point sources, and d is equal to lambda by 2. So shall I write and explain this question, or you want to read through this?
Sir, could you please write and explain, sir?
Okay. Have you written down the question at least?
No, sir, we're writing it down, sir.
Please write at least the question.
Yes, sir, I've written it down, sir.
Okay. Kavya, finished writing? Kavya UP, I think she has left. Purva Chandra Prakash, have you finished writing?
Yes, sir.
Shall I write and show all of you?
Yes, sir.
Purva Chandra, shall I write and show?
Yes, sir. Yes, sir.
Okay. So now what we have is 4 isotropic point sources supplied with currents equal amplitude and equal phase. So what is this broadside array? Agreed. But he has also asked you to derive the equations required. Derive the equations required. Okay. So let us start. What is n is equal to 4? Okay. N is equal to 4. What is D? Mahima, be with me. D is equal to?
Lambda by 2.
Very good. Lambda by 2. What is psi equation? Beta D?
Cos phi
Plus?
alpha.
Okay. What is alpha value here? What is alpha value here? Read the question. Anything given?
In phase current, something is written, sir.
In phase. This is in phase. Okay. This is IN. In phase. Can you see? This is in phase. This is in phase current. So in phase currents means what is the phase difference?
No phase difference, sir.
Yes. So your alpha is equal to one big anda here. Your alpha is equal to 0. So what you will get? Psi is here only beta D cos phi. Agreed. Purvachandra Prakash.
Yes, sir.
Okay. Harshita. So what is the value of beta, Mahima? 2 pi by?
2 pi by lambda.
Very good. What is the value of D?
Lambda by 2.
Please substitute in the above equation. So your psi will be equal to 2 pi by lambda by 2 cos phi plus 0. I'm just writing it for your understanding. So lambda get cancelled, 2 get cancelled. What you will get is pi cos phi plus 0. That is your psi. Our psi is equal to pi cos phi. Okay. Next one, first one, major lobe. Major lobe. Okay. At maxima direction, phi is equal to phi max and psi will be equal to 0. Okay, psi will be equal to 0. Whenever you are equating the sine and psi by 2, that is a different case, but angle psi will be equal to 0 at your maxima direction. That is what we have done in the previous question. Remember? Mahima, do you remember? Just
Yes,
now we
sir.
have done psi equate to 0 for major lobe for these problems. So when you equate psi is equal to 0, so what happens is pi cos phi maximum is equal to 0. Agreed? Agreed?
Yes, sir.
Yes, sir.
Then cos of phi maximum is equal to 0 because pi cannot be equal to 0. Therefore, cos of phi maximum is equal to 0. Okay. So what happens here will be phi maximum is equal to cos inverse of 0. What is that? 90 degree. Agreed?
Yes, sir.
Yes, sir.
So this will be, you can write as plus minus 90 degree or 90 degree or 270 degrees. See, actually you don't have to do this derivation only. See, if you read the question, since he has asked you to derive, draw a radiation pattern or array of 4 isotopes separated by distance of lambda by 2 having in phase currents, derive the equation involved. That means it is in phase currents means it is broadside array. So where will be the maxima direction?
90 and
Broadside
270.
array, where will be the maxima direction?
90 and 270.
Without even deriving, I know that. But you can't straight away draw. Otherwise, you can simply draw the radiation pattern because there is nothing in the question. That is why he has told derive the equations required. This has come as a 10-mark question. Please remember, you already know the answer. Broadside array means where will be the radiation pattern? 90 or
90 degrees.
90 or 270 degree. But in order to get the marks, you need to derive and prove that it is 90 and 270 degrees. Understood?
Yes, sir.
Yes, sir.
Okay. Fine. So we got 90 degree. Next, we should know is subsidiary maxima, subsidiary minima, and subsidiary maxima. That is next is side lobes. In that, first we will find the minima direction. Minima. Minima, what I have to do? Sine of n psi by 2 equate to 0. Okay. So n psi by 2 is equal to 0. So your n psi by 2 will be equal to sine inverse of 0. This I should equate to plus minus m pi. Okay. So your n is equal to 4. What is psi ma? Just now we have found pi cos phi. So your psi will be pi cos phi. What I should write here? Minimum, right? Yes or no?
Yes, sir.
Yes, sir.
Okay. Pi minimum. So quickly substitute this in the above equation. So what will happen is 4 into pi cos phi minimum by 2 is equal to sine inverse of 0 is equal to plus minus m pi. Agreed?
Yes, sir.
Very good. Okay. So this will be 2 pi cos of phi minimum is equal to plus minus m pi. Pi will get cancelled, right? So your cos of phi minimum is equal to plus minus m m by 2. So your phi minimum is equal to cos inverse of plus minus m by 2. Put m is equal to 1. Substitute m is equal to 1 quickly. What you will get? Phi minimum 1.
60.
What you will get?
60.
60 degrees.
You will get 60 degrees or 120 degrees, or you will get plus minus 60 degrees. Both are same. Now substitute m is equal to 2. How much you will get? Substitute m is equal to 2.
Zero.
Correct. M is equal to 2. How much you get? 0 or 180 degrees. Agreed. Now substitute m is equal to 3. Substitute m is equal to 3. Substitute n is equal to 3, m is equal to 3. What happens? You will get anything?
No, sir.
Write as invalid. Okay. This is known as your subsidiary minima because I have substituted equal to 0. Next, what I have to do? Subsidiary.
Maximum.
So the substitute sine of n psi by 2 is equal to plus minus 1. So your n psi by 2 will be equal to sine inverse of plus minus 1. Okay. Sorry. Sine inverse of plus minus 1. I can also write this as plus minus 2m plus 1 into pi by 2. Okay, for finding the subsidiary maximum. This is the formula. Please remember this. So n psi by 2 is equal to plus minus 2m plus 1 pi by 2. Okay, so what is the value of n? 4, right? N is equal to 4. What is the value of psi? What is the value of psi? Just now we have found out. What is the value of psi? Pi cos
Pi maximum. Pi cos pi maximum.
No, this is subsidiary maximum. Put here subsidiary maximum. Subsidiary maximum means these are side laws maximum and minimum what we are finding out. Got it?
Yes, sir.
Once 1 or 2 times you work out these problems, then you will understand. See, again you need to work out. That's why I'm working out with you instead of reading from the notes. So this is the phi of subsidiary maximum, that is equal to plus minus 2m plus 1 pi by 2. Okay. So this pi will get cancelled. This 2 will get cancelled. So right. So you will have cos of phi of subsidiary maximum is equal to plus minus 2m plus 1 divided by
4.
what? 4. So phi of subsidiary maximum is equal to cos inverse of, okay, plus minus 2m plus 1 by 4. Agreed. Put m is equal to 1. Now substitute m is equal to 1. Find out phi subsidiary maximum. Can you do that? Can you do that?
Yes, sir.
Okay. Please do that. Okay, now please substitute in this formula. Will you get the same thing what we have just derived? This will be plus minus cos inverse of lambda 2m plus 1. Maima, are you with me? Just put it in this equation. N is equal to 4. D is lambda by 2, no?
Yes, sir.
Okay, I'm just rechecking something. So what happens here? Lambda will get cancelled. Okay. So your 2 will get cancelled. Are you getting the same whatever we have derived now?
Yes,
Are you
sir.
getting? See now, why have not used this equation straight away? See, listen here. If it is a broadside array and end fire array, you can directly use this equation which we have derived, and you can remember that. Please see here. Lambda is equal to cos inverse of lambda 2m plus 1 divided by 2nt, where n is the number of points in the array and d is the distance between the array. And if n is very large, we have to do nd is equal to n minus 1 into d. That is what we have done as one problem, and we have found the half power beam width between the first nulls and this one. And if it is the end fire array, 1 minus 2m plus 1 lambda divided by 2nd. Now this is your subsidiary. Okay, this is your subsidiary maxima. Maximum you can find like this. Subsidiary maxima or minimum, whatever you call. Why I have not used this here? Okay. Can anyone answer why I have once again derived and not told you to use this? Please tell me, Maima.
So no, sir, I'm not able to get the answers.
No, you understood. If you substitute in this equation, you will get the exact same value as what we have derived now. Agreed?
Yes, sir. Yes, sir.
This is what you will get from this equation. Which equation? This subsidiary maximum equation, what I have drawn here, written here for your broadside array. Yes,
Yes,
or
sir.
no? Is it clear?
Yes, sir.
What we have done in the previous class on 30th October for subsidiary maximum for broadside array, this is the equation. This equation, if you know directly, you can use here instead of once again deriving like this. Now my question is, why have we derived once again instead of using it directly?
So they asked in a question to derive.
Huh?
Sir, in question it's been asked like we have to derive the equation, sir.
Please, why I am doing all that circus once again is derive the equations required it is asked, and it is a 10-mark question. So if I directly substitute, some 2 marks will be deducted from your final answer. So if you want full marks, you have to derive it. Otherwise, if you want to use it also, you can use it. So if you want to derive it, substitute sin n psi by 2 is equal to 0 for minimum direction. And for the subsidiary maximum, substitute equal to 1 plus minus 1. That time you have to use 2m plus 1 pi by 2, or you have to use m pi instead of when you are substituting it to 0. Is it clear? And for major lobe, you have to substitute psi is equal to 0, not psi is equal to 1. Whenever you are substituting sin n psi by 2 is equal to 0, that is your minimum direction for your side lobes. Sin n psi by 2 is equal to 1 is your maximum direction for your side lobes. But psi is equal to 0 is your maximum direction for the major lobe. Please remember that. Clear?
Yes, sir.
All of you clear?
Yes, sir.
Simply don't tell yeses, later you will suffer. If they have not as derived the equation, what you can do is this equation what we have derived on 30th October, this equation directly you can use. Is it clear?
Yes, sir.
Okay. Now you got it. Now substitute m is equal to 1. Find out the value of subsidiary maximum. Substitute m is equal to 1 in the above equation and find out the value. Maima, how much you get?
41.40 degrees, sir.
So your first one will be your plus minus 41.409 degrees. Okay. Now put m is equal to 2.
Invalid.
Hmm. Okay. Fine. Now let us draw the full pattern. Okay. Where is the maximum direction? 0 or 90 degree or 270 degree? What is the minimum direction? 180. Just now we have found is your first minima at 60 degrees and next minima at 0 or 180 degrees. So if you were to draw this, what you will get is you will get the maximum direction at 90 and 270 degree. That is your maxima direction. First you draw this maxima direction. First you draw this black lobes here. Okay, this is your 60 degree. You should have a compass and draw. This is your 60 degrees. And when you are finding out these angles, it will be plus minus 41.409 degrees or plus minus 138.59 degrees. So you have to do 180 minus this to get the other angle. 180 minus. Okay. How you got this? You got it.
Yes, sir.
Okay. So this will be your right here only. So 180 minus 41.409, you will get the other angle because it is a bidirectional lobe. So you have to find the other side. How much this will be? 138.99 degrees. Agreed?
Yes, sir.
Okay. Now how you have to draw? First draw the axis. First you draw the axis. Okay. After drawing the axis, you have to draw first your 90 or 270 degree. That is your maximum direction. So you draw the axis, then draw the axis at 60 degrees like this. Okay, this is your 60 degree axis. Similarly, draw it on the other side. First draw the major lobes as 90 and 270 degrees. So if I draw it here, it looks very ugly. So I will not do it. So that 90 and 2, whenever you are drawing, please remember your phi minimum comes at 60 degrees. So 60 degree, there will be no radiation. Your phi minimum direction is coming at 60 degrees or 0 degrees. There will be no radiation at 0 degrees and 60 degrees. So leaving that, you need to draw. So 60 degrees, there will be no radiation. And 60 degrees and 120 degrees, there will be no radiation. 0 degrees and 180 degrees, there will be no radiation. First, will you draw this between these two 60 degrees? Okay, what is the subsidiary maximum value, ma? What is the subsidiary maximum value?
41.
41.4.
See, listen here. There is one small mistake here. This 60 degrees, there will be no radiation because this is your 60 degree value. You got my point. This is your 60 degree. So your 41.4 degree will be in between these two. So you have to draw a dotted line here, and this is your subsidiary maximum. Can you able to see this? Can you
Yes,
able to see this? So similarly on the other side, that is 138.59 degrees. Similarly on this side, that will be 5 max 1 minus 41.4 degrees. That is your negative direction. This is your 5 max 138. That is this side, this side. So once you get this angle, draw the other one there, other one here, other one here. This is your subsidiary maximum values. Got it? How this is drawn? Purva Chandra Prakash, have you understood?
Yes, sir.
Any doubts, please ask me. Mahima, understood?
Yes, sir.
Okay. See, if you want very roughly, I can draw here. If this is your 41 degrees, once again 60 degrees I have to draw this. See, I can't exactly measure. See, you have to take your protractor, measure and do. So 60 degrees, you will get your first minimum. There will be no radiation in 60 degrees. At 41 degrees, that is your first subsidiary maximum, this one. So this is your first subsidiary maximum. So symmetrical on that side, you have to draw negative minus 41.4 degrees. That side symmetrical, you have to draw. So this radiation will come both sides. So what will be a beam width between first nulls? This is your no radiation. This is your no radiation. 120 degree and 60 degree. So what is this BWFN? 60 degrees between this and this, right? Because this is symmetrical. This is 60. So 90 minus 60 is 30. 120 minus 90 is 30. So we are right at the center. So what will be this BWFN?
60 degrees.
60 degrees. What will be half power beam width?
30 degrees.
Very good. Have you understood how to draw this plot? After you find out, all of you understood?
Yes, sir.
Okay. Rainak Sharma, did you understand?
Yes, sir.
Okay. Shall we do one more problem? Shall we do this problem? Mahima, one more problem before we end the class.
Yes, sir.
Oh, very good. Purva Chandra Prakash, shall I do?
Yes, sir.
Tell properly.
Yes, sir.
Okay. You want me to write down the question or can you copy from here? Please write this. A linear array of 4 isotropic point sources with equal displacement of lambda by 2 meter, with equal displacement of lambda by 2 meter, but a phase shift of minus dr current plot the field pattern and determine half power beam width and direction of the nulls Have you written down the question?
Yes, sir.
Plot the field pattern and find the direction of the nulls. Very good. I'm able to see the question here only. Now tell me, what is the value of n ma?
4.
What is the value of n? N is equal to
4.
Maima, what is n? Maima, are you there?
Yes, sir.
Kavya?
There's a network issue, sir. So rejoin now, sir.
Okay. What is d? Lambda by 2 meters. Agreed? Okay.
Yes, sir.
Now he has given one phase shift minus dr. This is your phase shift term. Again, this is neither a broadside array nor an end-fire array. This is somewhat hybrid in between that. So please write down dr is nothing but beta into d. This is what is given in your textbook, John D. Cross. Please write down dr is equal to beta into d. Okay. So your minus dr will be equal to minus bd. Agreed?
Yes, sir.
Okay. Minus beta into d. So what is your beta? Minus 2 pi by lambda. What is d? Lambda by 2. So 2 will get cancelled. Lambda will get cancelled. You will have minus pi. Okay. So your psi will be equal to now beta d cos phi plus alpha. What is your value of alpha now? What is the value of alpha? Guess.
Minus pi.
Yes, excellent. So your beta d cos phi minus pi. That is your cos phi value. Now let us calculate this. So this will be equal to beta is equal to 2 pi by lambda, d is equal to lambda by 2 cos phi minus pi. This is your entire angle psi. Okay. So your lambda will get cancelled, 2 will get cancelled. So you will get pi cos phi minus pi. So your psi will be equal to pi cos of phi minus 1. Okay. Next, your major lobe direction. Major lobe direction. So what I have to do? Two questions we have done. So for phi is equal to phi max, equate psi is equal to 0. Equate psi is equal to 0. Agreed?
Yes, sir.
So I have to write here pi of cos of phi maximum minus 1 is equal to 0. That is your cos of phi max minus 1 is equal to 0 because pi cannot be equal to 0. So cos of phi max is equal to 1. Agreed? Okay. Next, what will be this? Phi max is equal to 0 degrees. Agreed? No 0 or 180 degree here. This 1 has come here. So this is only 0 degree. So this is a unidirectional pattern. Please remember this. This is a unidirectional pattern. Okay. Next, what I have to find? Side lobes. Agreed?
Yes, sir.
Next, first find the minima direction. How you have to find the minima direction? Sine of n psi by 2 is equal to 0. Agreed? So your n psi by 2 is equal to sine inverse of 0 is equal to plus minus m pi. Plus minus m pi. So n is equal to 4. 4 by 2. What is your phi value? Pi of cos phi minus 1. Pi of cos phi minus pi of cos phi minus 1. So this will be a subsidiary minima. That is equal to plus minus m pi. Okay. So what happens here is something I have left. Correct now? Bracket I had left. Agreed, Mahima?
Yes, sir.
So what happens? I'll quickly go through here. So this is what we have done. N by 2. Phi of cos phi minimum minus 1 is equal to plus minus n pi. So instead of k pi, I have written as m pi. So your cos of phi minimum. Okay, I'll quickly do this. Your pi will get cancelled. Pi will get cancelled. Finally, you will get a cos of phi subsidiary minimum. Subsidiary minimum is equal to 1 minus m by 2. 1 minus m by 2. Or phi of subsidiary minimum is equal to cos inverse of 1 minus m by 2. Now substitute m is equal to 1. Substitute m is equal to 1. Find out.
60 degrees.
Once more, this is plus minus, okay? So your plus minus will come. So this will be equal to plus minus 60 degrees. Substitute m is equal to 2.
Plus or minus 90 degrees.
3.
One 120 degrees.
Okay, 120 degree. Plus minus 120 degree. Continue. M is equal to 4.
One 180 degrees.
M is equal to 5.
Invalid, sir.
Very good. See, you don't have to know. Here you have found the subsidiary minima. So in between your subsidiary minima, directly your subsidiary maxima will come. So in order to save the time, you need not find the subsidiary maxima. We'll try to directly plot this one. What is the maximum direction we have got? 0 degree. Where is the first null we are getting? Sorry, first minimum direction? 60 degree. So where will be the radiation pattern? Where will be the radiation pattern?
0 degrees.
Very good. So your radiation pattern will be something like this first. This is a unidirectional pattern. So this will be your 60 degree thing here. Similarly, this will be your minus 60 degrees. Okay, what will be your BWFN, beam width between the first nulls? I'm doing it very fast. No.
120 degrees.
So one subsidiary maximum we'll try to find. For subsidiary maximum, what we'll do? Your sine of n psi by 2, I have to equate to plus minus 1. So I have to equate the sine of n psi by 2 is equal to plus minus 1. This I have to equate to 2m plus 1 into pi by 2. N is equal to 4. N is equal to 4. So what will happen is 4 by 2. Okay. Wait. So one small this one, n psi by 2 is equal to sine inverse of plus minus 1. Sine inverse of plus minus 1 is equal to plus minus 2m plus 1 into pi by 2. Agreed? So this will be
Yes.
4 by this will be 4 by 2 pi into cos of pi subsidiary maximum minus 1 is equal to plus minus 2m plus 1 into pi by 2. So your pi will get cancelled. So you will get cos of phi subsidiary maximum is equal to plus minus 1 minus 2m plus 1 divided by 4. So your phi subsidiary maximum is equal to plus minus cos inverse of, this will be 1 minus 2m plus 1 by 4. Okay, so this will be a final, this one, substitute m is equal to 1, find out the value of phi max, phi subsidiary maximum.
(75.52 degrees). Plus or minus 75.52 degrees.
Okay. Next, find subsidiary maximum 2. M is equal to 2.
60 degrees.
Huh? M is equal to 2. Find out 105 degrees you will get.
Not 4.47.
Huh? So approximately 104.47. Okay. Next, M is equal to 3.
138.59.
Huh?
138.59.
This is your maximum subsidiary maximum. This is your subsidiary minimum. Okay. Now what you have to draw is, first you draw the major lobe, 60 degrees you mark. 60 degree, 60 degree, like this. 60 degree, 60 degree. So your entire radiation direction will come between 60 degrees and 60 degrees. Got it? Got it?
Yes, sir.
Yes, sir.
So what will be a beam width between the first null? 120 degree. So what will be your half power beam width?
60 degrees.
60 degrees. Very good. Now next, where is the first maxima direction coming? Okay, next, that is your next minima. Where is your next minima direction coming? Plus minus
90 degree.
90 degree. So plus minus 90 degree means here plus 90 you draw one minima, minus 90 they draw one minima. So there will be no radiation in between that. So where is your first subsidiary maximum coming?
75.52 degrees.
Okay. Approximately at 75 degree. Now don't start measuring 70.5 in your protractor. Approximately measure 75 degree and draw one small subsidiary maxima here. Similarly, it will be on the opposite side. That will be your minus direction also. You will get one subsidiary maxima. That is, this is your first subsidiary maxima. Next, where is your next subsidiary minima? 120 degree. So where will be the radiation coming? Between 90 and 180 degree. Because between 60 and 90 are already done. Next radiation pattern will be 90 and between 90 and 120 degrees. Where is that next radiation pattern coming? 104.47 degrees. So there you have to draw one more small subsidiary maximum, 104.47 degree. That is your next subsidiary maximum here, 105 degrees. Agreed?
Yes, sir.
Yes or no?
Yes, sir.
Okay. Why so small voice? Rainak Sharma, understood?
Yes, sir.
Okay. So where is the next subsidiary maximum coming is 138.59 degree. Where is your next minima coming? 120 degree and 180 degree. So in between that you will get one more radiation pattern here. So yeah, this is your next radiation pattern, 138 degree that you have got one more radiation pattern. This is not 150, 138 point this one. So but your beam width between first nulls will be 120 degrees. I think it is absolutely clear, these problems.
Yes, sir.
Okay. So this more or less finishes the 1.5 modules from my end. Third module and the fourth module half. Now I have to start in the next class electric dipoles and thin linear antenna. That will be the second part of the fourth module. you have a lot of derivations here followed by some problems. Then we'll be going to your fifth module. In fifth module also, okay, we'll be starting with helical antenna. Okay, in that fifth module, part 1 is quite little bit easy for you. So this is what I'll be doing next. This I can go through a little faster because you have more theory portions in this fifth module. I need not write down each thing. But your fourth module, part B, is again little tough. So I need some time to cover that. So this is your fifth module. In the fifth module, second portion, all this is horn antenna and helical antenna. So then you have problems on horn antenna, helical antenna. This I'll be doing little faster. Then you have what is known as a loop antenna. This will take little bit time. So this is what is left in the syllabus from my side. So fourth module exactly I have finished the half right now. Okay, ma. Any doubts, anyone?
Sir.
No, sir.
No doubt, sir. No, sir.